Reduction of monosaccharides. Okay, so remember with reduction here, what we are looking at is reducing the number of carbon-oxygen bonds. Okay, so we're going to be focusing on this aldehyde group here in xylose. Okay, a simple monosaccharide. Okay, so we're going to be doing a reduction. We're going to use hydrogen with a metal catalyst. Okay, and by looking at this configuration and looking at the chiral carbon that is furthest from that most oxidized carbon, this is the D configuration. The OH here on this last chiral carbon is on the right side, so this is D-xylose. Now when monosaccharides go through reduction, you go from the monosaccharide, from the sugar, and you become sugar alcohols, what they call sugar alcohols. Okay, sugar alcohols, there, you should say their fancy name, their proper name is aldatols. Aldatols. And you may be familiar with some of these, sorbitol, mannitol, xylitol. You might be familiar with these in chewing gum, sugar-free treats, and sweets that are sugar-free have the, what is it, Mentos candy, I believe, has got sugar alcohols in it as well. So what happens is we go from the carbohydrate, from this monosaccharide, the reduction takes place and we become a sugar alcohol. We focus in on this aldehyde group, so we keep our structure intact as far as here is that last chiral carbon and then the next one. So that stays intact. We get to this aldehyde group and we're going through a reduction process. So we turn it into a sugar alcohol. So it becomes CH2OH with this right here. Let me change colors here. This, you see, is now a carbon with 2 hydrogens and the alcohol group. So we went from this carbonyl aldehyde group here, we reduced the number of carbon-oxygen bonds, introduced the hydrogen, took them, and there's that alcohol, that hydroxyl group. So we went from the aldehyde in this aldose, this monosaccharide, to a sugar alcohol, and this would be xylitol. Xylitol, common sweetener found in many sugar-free gums and candies and snacks. Okay.